else can we get weather data in the aircraft today?
Yeah, transmit.
Data links, like Sirius XM. That's why Sirius bought XM radio, to get all the data link contracts. How else can we get weather data?
To look outside.
That's the Sirius XM type data link, satellite data links.
The lightning?
Lightning detectors, very good. Today we have a lot of data links available. ADS-BN, we can get all that stuff on. We can get weather maps, radar, and ground radar has a lot better resolution than airborne radar does. Bigger antennas, a lot bigger antennas. Even the one in my airplane was not 60 inches in diameter. The ones on the ground are 65 feet in diameter. They have a better resolution.
Damn.
So it can be on board radar, it can be a digital data link of some kind, or we can use lightning detectors. And if you got two of those, you really know a lot. And that's why even light planes today have at least lightning detectors in them. But even biz jets and airliners have lightning detectors in them. Why? If I use that with other stuff, if I put it all on my multifunction display, I can really see what's going on. Almost all the navigation systems we talked about use radio. We talked about ADS, VORs, GPS, RNAV. No RNAV questions. Is there a way I can navigate that doesn't need radios accurately?
Transcontinental airline.
I'm asking a question, so the answer is yes. Another big one is it?
Yes.
I mean, you navigate with GPS.
Huh?
Navigate with GPS. It's
Not best use of radio.
You can navigate that site if you're low enough.
I want to fly from here to England. The ocean is a big empty
How'd
place.
you wanna do that?
A compass.
Relative something.
Damn it, what's it called?
Dead reckonings are last ditch.
Section.
That also, most aircraft today do not have astrodomes on the top. That you need to use the section.
Use like alternate time. No, that's pretty.
It starts with the word inertial.
Oh, INS.
INS, inertial navigation system. If I know every single movement, I know exactly where I am at any given point in time. I know how far I walked, when I turned, how fast I was going, all that, I can reproduce it. I talked about get me over to Sonic. If you tell me you go so many steps, turn, go downstairs, do all that, I can do it blindfold. And that's how inertial navigation works. It tracks every move. It integrates it, it calculates where you are from that. And in 1 hour, it has to be within 1 mile of accuracy. 6 hours across the Atlantic, you're gonna cross the coast within 6 miles. You know what, then I can look out the window and kind of. Plans, that's when we talked about things like ring laser gyros and cool stuff.
They should make a plane with no windows. One big ass market on it.
One of the problems we have today,
Get rid of the
lots and
wings.
lots of electronics in the aircraft, is great potential for interference.
Goddamn flying coughing.
What is one of the most important things about reducing or eliminating interference? What do we do? And spacing, bonding. That's the big one. Bonding and shielding. Bonding, anything that gets to anywhere gets routed off to the airplane, jumped out in the air through our discharge works. Remember that?
Mhm.
Yeah. Shielding keeps stuff out of the wire we don't want there, and keeps stuff in the wire that we do want there. Yeah, the other stuff, yeah, there's other things we do. Like keep stuff a distance apart, don't want different signals travel over each other, don't tie into common ground. Those are the two things, bonding and shielding. Bonding, one of the causes of electromagnetic interference is static buildup. It happens, and even an aircraft with discharge wicks or whatever, it can happen. I've seen almost fire in flight. It's really cool, kind of spooky.
Kinda.
If you've ever seen pictures of a helicopter landing at night, you've seen it, where it looks like the rotor blades are a glowing disc. That's St. Elmo's fire. It happens on props. I've seen it form on the windshield. I've seen it, yeah. Even with them, that can happen, which is not as likely. When it does happen, it's almost always gonna be some of a proper rotor that we can't really bond. So that's where it goes. Hopefully that can be here. And one of the problems we have is we're gonna mount the radios on shock mounts. And what are the shock mounts made of?
What was it?
Rubber.
Damn it.
Is rubber conductive?
No.
Oh,
So what do we gotta do then?
wire it.
You put a bonding jumper on. It goes from the radio down to the airframe.
I couldn't figure out where it
Ground is.
I just went,
What's the maximum resistance on a bonding jumper, Cash?
0.003.
What's the max resistance on a bonding jumper?
0.0.
0.003.
Yeah, 0.003. You had it trailed off.
Too many decibels.
If nothing else, I think you guys will all get that one now. We have to use special testing equipment to test that, because a regular multimeter won't do it.
3,000 is too low.
That's too low. Let's see, oh, antennas. So I'm gonna install an antenna, I gotta put a comm antenna on top of my airplane here. First thing I gotta do is drill a hole, several holes. One to the antenna lead, one's the mounting hardware. Do I just bolt it to the skin?
doubler.
Need a doubler. What's the doubler have to attach to?
Ribs.
Hmm?
Structural.
Primary structure.
Okay.
Stringers, formers, bulkheads, whatever it may be. Usually, it's gonna be stringers or longerons. We may not be close to a bulkhead or a former or something, but if we've got them, we'll use those too. I've got antennas that we tie in on all four sides, especially here. The skin can't take the load. That's why we have to transfer it into primary structure. And that's what the double is for. Let's talk about autopilots. Autopilots have several different parts. What's the sensing part?
Gyro.
Huh?
Gyro.
Gyroscope. What's the output element?
Servo.
The servo. What is the computing element?
Flight controller? I don't know.
If it's digital autopilot, it's the computer. On the other hand, what do I use to tell it what I want it to do? That's the flight controller. That's the box of the switch. Now, most systems today have another one. What's that fifth function that we need?
Follow up.
The follow-up signal. Why do we have that?
So it knows how much it's,
I can answer that question in 2 words.
Error signals.
Prevents overshoot. Without follow-up, all the airplane knows is, I'm not going the direction I want. I want to go that way, I go that way. So it tells the ailerons, bring it back on course, they do. Oh, I'm on course now, you can stop. Now I'm over here. So it tries again, you're good, and now it stops. With follow-up systems, as soon as I start moving, the ailerons in this case start reducing. They're telling the autopilot computer exactly how far they're deflected. It's going, this is how far I'm off course. The closer I get, the less the ailerons. So that when I get back to here, I'm level. Or overshoot. This is one reason why the King digital flight control system we saw goes in a lot of airplanes. We use it in light pistons, twins, all the way through some jets. But it has to have stuff done to it every different airplane it comes into, because it has to understand its response. That's one of the things the avionics guys do, is they load that in. It's like performance Okay. So the overshoot is eliminated by the follow-up system. If I ask you about what the follow-up system does, prevents overshoot. That's the key part. Remember, I can let it fly the airplane, or I can use the controls to fly the airplane through the autopilot and turn the knob to bank, or turn the wheel to pitch, and that stuff. On the other hand, I can tell it what I wanna do, and then it can tell me how to fly the airplane that's flying directly at me. Some aircraft need yaw dampers. The 787 probably has one. What's the purpose of the yaw damper? That's the answer, help prevent Dutch roll. Dutch roll at the very least is unpleasant for the passengers. Like, if you're back in the back, you'll get airsick, almost anybody will. At the worst, it can become divergent, break the aircraft off the plane. We don't want that. Bad press. Remember, you never wanna kill the passengers, it's bad for business. You kill them, they can't buy more tickets.
Ryanair says otherwise.
Now, we talked about auto pilots, we talked about all the way from the really basic single axis wing levels through autopilot systems that can control up to 3 axes. And then we got into more advanced stuff, like automatic flight control systems, okay, for example. What can AFCS do that autopilot can't? That's the first one. That's one of the things that makes it an AFCS.
Auto land, it can completely land itself.